Hello, everybody, and thank you for joining. My name is Paul Murray, Product Leader for ROTOWELD 3.0 here at Technar Automation. And I'd like to thank everybody for joining our webinar today, for taking the time out of their busy schedules. This session will be recorded. We'll disperse it after so you can review all of the content and close. And I'd like to let you know that at the bottom of your screen in Zoom, there's a Q&A function. So at any time throughout the demo or my presentation, you can ask questions, and we're going to get to them towards the end of the presentation. And we can stick around on the meeting for Q&A for an open dialogue if that's necessary. So kicking off with a quick agenda, there's going to be a lot of technical information, and I'm going to move along fast to keep the schedule short. So again, feel free to use the Q&A function or to send an email to info@rotoweld.com with any other questions. So diving right into our agenda, I'll start with a quick presentation on who is Technar, what do we do, and then jumping right over to the ROTOWELD website where I'll give a tour and orientation of the system. And the nice part about that is you can visit rotoweld.com at any time and sort of follow along the presentation I went through today with all the relevant information. After that, we'll step out to the shop floor, quick tour of the components of a ROTOWELD, and then we'll dive right into our demo on our 8-inch Schedule 40 carbon steel pipe, which we're going to weld from root to cap. Beginning with the presentation. So who's Technar Automation? Well, we're founded in the early 1990s, and our job is to turn science into durable innovations. And a good example of that is the ROTOWELD. The first ROTOWELD was invented in the early 1990s, and it was a breakthrough because it uses machine vision and motorized controls to act like the welder's eyes and hands, and to perform open bevel pipe welds automatically. So building off 30 years of experience and advancements in technology, we've arrived at the third generation ROTOWELD 3.0. So heading over to rotoweld.com, we'll start with why ROTOWELD. Why do customers buy ROTOWELD, and why does it work so well? The first reason is that we require minimum welding experience. So through managing the arc through the camera and robotic controls, new operators are easy to adapt to this quickly and easily. And the average training is less than 2 days for new operators, and even quicker for experienced operators because it's very intuitive. Using the joystick is just like using the welder's hands, except that they're separated away from the heat and intensity of the arc. The average welding shop who adopts ROTOWELD from semi-automatic MIG welding is going to realize about a 400% productivity increase versus their old way. And moving from stick or TIG, we see even greater gains than 400% due to the speed of the automatic GMAW process. A big key for us in welding automation is to produce a high quality weld every single time. It's very important when automating that we have a high level of quality and that we understand what contributes to quality. So with a ROTOWELD in our automatic welding mode that you'll see during the demo, we're actually adapting to things like changing gap, land, and high-low situations on the fly through our adaptive vision. Critical to the QA and QC side of critical welding is the remote tracking of every weld that you make. So every ROTOWELD is equipped with our Pro Data Log, which is a cloud monitoring software that's absolutely free and provided to you. This allows us to track job ID, welder ID, and even right down to the part serial number, and then to view in the cloud the actual procedures and settings used on a second-by-second basis. We can generate reports, and we can actually withdraw the high-quality video that was taken during welding and save that as well. So you'll notice today during our Zoom demo, the camera quality that Zoom pushes is a lot lower than the image quality we're actually capturing and what the welder's actually seeing while welding. So at the end of the weld, I'm going to hop onto the Pro Data Log and show you the actual footage that we capture, because again, Zoom is pushing it at a lower frame rate, and it tends to look a little bit darker in the Zoom presentation than it does in real life. Every ROTOWELD is customizable to your reality. So we fabricate complete turnkey systems, but we do it in different shapes, sizes, configurations, and we have a few different options. And I'm going to get to that in just a moment. And the last point, most importantly on why ROTOWELD is improving the welder's working conditions. So with the growing skills gap, it's important not only to increase the individual welder's productivity, but to make the job safer and more alluring to the younger generation. So by getting the welder away from the heat, fumes, and UV radiation of the arc, we make it a less strenuous job, less weaving, less manipulating the torch by hand. Well, no manipulating the torch by hand. So we're eliminating all wrist, back, and neck strain as well at the same time with ROTOWELD. Moving on to our different models, I'll run this video in the background while I talk, which is a ROTOWELD twin bay. So the difference between a single bay and a twin bay is that a single bay is your entry point into the automated pipe spool welding with a ROTOWELD that's going to have one positioner and one robotic travel carriage. The twin bay is really the next step up because we maximize arc on time and achieve the ultimate results for factored diameter inches per day. Because as you can see in our video, while one bay is welding, a second operator can be loading and feathering the tacks, preparing the spool for as soon as the first operator is done on the first spool. This can be obviously alternating back and forth at any time, and this is how we really crank up our arc on time. So we get to talking in welding automation a lot about the pounds per hour of the process. Pounds per hour is kind of like the horsepower, but what we actually want to know is what's our operating factor, and that's more like our true 0 to 60 time, our acceleration when everything's factored in. So by having the highest possible pounds per hour multiplied by the highest possible arc on time, this is how you achieve truly state-of-the-art, high productivity with welding automation. It's not just about what you can offer in a pounds per hour standpoint. We also have the difference between a standard duty and a heavy duty. A standard duty turns from 3 to 42 inch pipe and has 10,000 pound idler supports, which you can see 2 per bay in this video, while the heavy duty goes from 3 to 48 inch on the positioner and has 15,000 pound idler supports. The other difference with the HD is that we gain an additional 6 inches of center line clearance between the chuck and the base. So for a total on the HD of 71 inches as compared to 65 inches on the standard duty. The reason for this is we want to maximize turnability of parts in your shop. The more parts we can turn and weld in the 1G with ROTOWELD, the more productive and profitable you'll be. We also offer a couple of options on any configuration. So on any standard duty or heavy duty or single twin, all of these options are available. So first is slip-on flange welding, which makes program creation for fillet welding very easy because the ROTOWELD positions its arm automatically with its servo drives to go to the correct location for fillet welds or butt welds when you have this feature. So again, maximizing the amount of welds we can make on our automated cell. Next option is our fume extractor. What's very unique about this is that the ducting is all contained in our cat track, and the hood is going to follow the robotic arm to every single joint on every single spool with very little positioning dependent on the operator. And source capture is one of the most effective ways to eliminate welding fume and have a safer welding workshop. The environment, not only for welders, but for everybody working in the shop environment. We offer a submerged arc welding option where we equip our ROTOWELD with a Lincoln FlexTech 650 power source, torch for the root welding, and the torch for the sub-arc as well. So what that allows us to do is make root passes using the GMAW process. And then with our procedural database and knowledge, we can go straight to a hot pass with submerged arc, as well as filling and capping. So we can really get some great mechanical properties using the submerged arc welding process. Another nice feature is we make flux catch bins, which hook onto your idler rolls, sit beneath the joint, and capture all the unused flux spilling off the pipe, and they're easily dumped into a side receptacle for reuse. And a couple of smaller options we have are drive rolls for flux core or metal cord arc welding, stainless steel grippers to avoid contamination on alloyed pipes, and rubberized idler rolls, again, for the same reason, to avoid contamination on your alloys like stainless or duplex. Last but not least, I'd encourage you on your own time to take a look at the case studies tab on our website. It's a great resource because it shows you real workshops around the world who are using ROTOWELD, and you can actually get some access to the stories, a few quotes, interviews, but most importantly, really nice high quality images of real parts being welded in real shops all around the world. So this concludes my website presentation. So I'm going to switch cameras here, and I'm going to head out to the floor to our ROTOWELD twin bay system and give you a full tour, followed by our demo weld. So this is our ROTOWELD standard duty twin bay model. And the first thing I want you to notice is this is a compact assembly intended for factory testing. So we've only got one set of length of rails per positioner, which is 16 feet from the chuck to the end. But normally we do a configuration really to suit your needs. But most common is a 20-foot primary bay and then a long bay on the end so you can weld a variety of spools with the minimum floor space required. Talking about our base, we don't depend on a level floor to achieve a level spool because we have leveling bolts all throughout our track sections, which allow us on any floor to achieve a perfectly level track. And that's very important because the backbone of the ROTOWELD is its rail-based system. And by that, we mean the first set of rails where we have our traveling pipe supports. So these are very, very easy to move. They're engaged hydraulically very quickly. They come up and they're always in perfect center alignment with our chuck and therefore with our spool. So this makes setup very, very quick. And it's another way we're maximizing arc on time, not just the pounds per hour of the welding. Following along our rails to our positioner itself, we have 50,000 inch-pounds of turning torque, and we make a counterweight as well. So when we get into bigger elbows and fittings that exceed the 50,000 inch-pounds of torque, we offset it with a counterweight, and we're still able to turn large and complex parts. We've had customers turn parts with a diameter of 1 meter and with enormous elbows, and using the counterweight, it's totally possible to be done on the ROTOWELD. Another feature of each positioner when it's not in use and the carriage is welding on the other bay is the set of individual foot pedals. This is what allows a second operator to be feathering tacks, loading the spool, and having it ready so that as soon as our arc's done on the other bay, we come right down and begin welding, again, maximizing our time with the arc on. The second set of rails that I'm standing on the bed of now that's critical to ROTOWELD is our rails for our traveling carriage, which moves from bay to bay and joint to joint on an individual spool. So you'll notice we have our cat track here and following me along to the primary bay. So with our cat track, we have no cables on the floor. Everything's automatically managed as the operator travels up and down bay to bay. So with ROTOWELD, there's no tripping hazards, no wires, and no damage ever done to things laying exposed on the floor. In the primary bay, you'll notice it's basically an exact replica of the second bay. They might be different in length, sometimes in configuration, but what we have is, again, another 2 pipe support stands and an identical positioner. The only difference is in the primary positioner, we're housing our welding power source down in our panel here, which is closed off to be kept free of grinding dust, dirt, and other hazards in the shop environment to maximize the life of our welding power source. Taking a closer look at our robotic arm, this is driven by 0 backlash harmonic drives. And when we call a welding program for an 8-inch pipe and we ask the arm to go, it moves to the position on the 8-inch pipe with the correct welding angle for root pass and fill pass welding. And it does this with the touch of one switch. There's no robotic welding programming required with ROTOWELD to make the arm move to the correct position. It's just a matter of naming the diameter of the pipe and hitting go. At the end of our arm, we have our camera, which allows viewing of the arc in the open bevel during welding. So it gives the welder a very, very good view, a lot like they would see with their own eyes when performing an open bevel weld. We have 2 torches. We have our air-cooled root pass torch, which allows us to get tight into the joint with smaller consumables. And then we have our large 600 amp fill pass welding torch, which is perfect for the continuous welding when we get onto large diameters. We won't get into any torch overheating thanks to the water cooling. The other advantage of a twin torch design is that we're running 2 wires and 2 gases. So we have an individual root pass wire and gas. These wires are fed off standard 4-roll Miller drive units. So all drive rolls, guides, things like that, replacement parts are all off the shelf, replaceable locally at a low cost. Taking a quick look inside our cabinet, we can see where we keep our consumable wires. We have our root pass wire and our fill pass wire. And this is very important because sometimes in more critical procedures, we'll run a solid wire root pass and maybe a flux core or metal core fill pass, where we're using a different gas for each wire and the two different wires. But this results in zero changeover time for the operator. They make their root pass and then they transition directly to their filling passes, and they don't need to make any switches of consumables or gases. We have an option for bulk consumables. So to the side of our carriage, we can mount large wire drums if you require something larger like a 500-pound drum as opposed to the 44-pound spool. Taking a closer look inside our cabinet, we can see our Lincoln PowerWave STT welding module. This is what allows us to perform the root pass with a super high quality. STT was developed in the 1980s and is very, very mature. And it's known as the de facto standard for root pass pipe welding. In the base, again, we're protected from debris and dirt. We can't see it, but it's our Lincoln PowerWave S500. And the unique part about the S500 is it has a customized arc for every application. So when we get into different things like carbon steel as opposed to high strength, low alloy, stainless steels, duplex, there's always the right weld mode for the wire and gas combination that we want to use. So this gives us the perfect arc for every application. Very important to the operator is our control panel. It's simple, easy to use, and it's very intuitive. And it's where the operator who's doing the welding interacts with all aspects of ROTOWELD. The joystick is basically where they always keep their hand because it has 3 different roles. When we're not welding and we're positioning for welding, the role of the joystick is to control carriage movement up and down the welding track in its first axis. And in its second axis, it's rotating our positioner to allow us to get ready to start our weld on attack. The second role of the joystick is during welding. So this is our left and right steering to maintain centering in the joint. It's also our up and down to control travel speed and arc position in the open bevel. There's some easy to use switches, which give us parameter change on the fly if we need an extra half a volt, a little bit more wire, a little bit more weaving. The operator can actually add this very easily using these toggle switches along the bottom. And then the third role of the joystick, and I'm going to share our user interface. Now you're able to see the ROTOWELD user interface on your screen. And I want to take a moment to point out to you that on your screen, between the ROTOWELD view that you see and our camera view, which is probably quite small right now, there's a small white tab you can grab with your mouse and drag to even out the views between the live camera and the ROTOWELD screen. So navigating our user interface, that's the third role of the joystick. So we're able to select operator ID, job ID, and even individual part serial number. And this is what gives us the ultimate traceability. So very easy to use. When we want to change a welding program, we highlight our welding program name selection, hit enter. We can scroll through our list for different pipe diameters and applications that we have saved in our library. And to back out and cancel, we simply hit stop and back out. At the bottom of our screen, we have our at glance of our welding procedure. So here the operator can quickly see they've called up their program. Okay, this is going to be a 3-pass weld with a root, a fill, and a cap. Settings look good, let's go. And normally the settings are locked out after engineering development's done. So the operator can make about a 10% change to these settings, but the procedure is going to be right every single time a program's called up. And last but not least is the large center area of the screen, which is where we view our welding. So when positioning on the pipe, which you'll see momentarily during the demo, our LED array illuminates, and we can see our torch position in the bevel before welding. And when we start welding, it actually darkens just like a welder's helmet, and we have the perfect filtered view of our root pass and our fill and cap pass welding through the camera screen here. So it's mimicking the real view of the weld without the UV radiation or the heat of being near it. So with this portion of the tour done, I'd like to introduce Chris Trudell, our senior service technician, who's going to be doing our demo today on our 8-inch Schedule 40 carbon steel pipe. Chris, I give the floor to you.
Hi, everyone. So nice to meet you. I've been with Technar for 30 years and installed many of these around the world. So I'm going to try to explain what we do and how we do it. So, so right now, what we've got is the 8-inch Sched 40 with the proper welding program already in there. So now all I need to do is I will put the sensor for the root pass, which is required for the power wave. Then I will lay down the arm to the proper welding position, which the machine knows because it knows the size of the pipe. And we will be welding 45-degree downhand for the root pass. So my sensor is installed. So basically, just lower my torch. Then I will move the carriage to bring it near my joint. I will start on the middle of a tack. Just set the stick out I want. Rotate my pipe. Put that on my middle of the tack. Proper stick out. And then I look on my camera on my screen right here. And I can center it on my tack. So now I'm in the middle of my tack. Basically, I will press start and we will start to weld. So what we need to understand here is that during the root pass, basically what we do is that with the simple move of the joystick, we're able to control 4 welding parameters at the same time. So basically we have the traveling speed, wire feed rate, voltage, and oscillation. So when we're doing the root pass, with the joystick up and down, we're controlling the traveling speed. So what the machine does is when the traveling speed is changing, all the other parameters will change automatically depending on the traveling speed it's going at. So this is what we call the 4D synergy. So from there, we will establish the arc, put the puddle where we want it to be to have proper fusion. And once we're there, by simply pressing enter, we will add another layer, which is the rotomatic, which basically will be looking at the screen, analyzing the image, and it will speed up or slow down according to the gap variation. And from there, 4D synergy is always working in the back. So I'm ready to go. Just press start. And up or down, so I control my traveling speed. So right now I'm slowing down a little bit. So right now what I see is I see my 2 root face in the puddle below it. So this is what I want to see. When I see this, I know that my penetration is good and I'm all fused inside the pipe. So from here, right now this would be manual mode. If I'm not changing its traveling speed with the joystick, it all stays the same. Now if I add the rotomatic on, there we go. I just set my reference. And from there, the machine is actually looking at the image, analyzing the image. And it's changing the traveling speed accordingly to the gap to still achieve proper fusion. So of course, I need to steer right or left if need be, a bit faster if need be. And then what we need to keep in mind is that every prep is a bit different and we need to adapt to the gap. And this is exactly what it does. If we would have a machine that requires always the same preparation all the time to have the perfect welds, this would not be efficient in the pipe spooling industry. So now I'm getting on the tack. So the machine will speed up a little bit. And then when we will exit the tack, it will slow down and keep going in the root gap. I can make it a bit to the right. Tiny bit faster. There we go. So this is what's special about it, is that it will look at the image, it will adapt to the root gaps because it's necessary in this industry. So this is how the root pass is working. Next, when we will go on the filling passes, the filling passes are actually fixed parameters. But like Paul said before, I have my override. So when I will be in my hot pass, I will be welding. And if I need to adjust a little bit, I have my override here. So wire, volts, oscillation, or traveling speed. But once the program is properly set, I mean, there's not much to do. It's just to pay attention to little details to make sure we have proper arc location on the root pass and as well on the hot pass and cap. So another attack is coming here at the left. Machine is speeding up a little bit, going through the gap, through the tack, sorry. Slowing down at the end of the tack. So we can see that the arc is really in front of the puddle. How do I know that? I can see the splatter going through the gap. So the arc is really making the fusion here, which is really important. We don't want the arc to be on top of a huge puddle. That would be just, pouring metal in the root opening. Steer it right or left. Go. So we put root face. Basically, the main reason is that it's holding the puddle there. So it's easier to weld. And if we melt all the root face, well, we know that we have a good fusion because the root face is about 332, which is pretty thick. So if we fused everything, if we fuse the root face, we know it's all good. So we're about to close the weld right now. I'll just remove the automatic mode. Root pass is pretty much done. So from this point, I will just remove my sensor, raise the head a bit, and position myself for the filling position for the hot pass. Just remove the sensor. Raise my head, lower it, and then it will reach my filling position. So we change position basically to achieve, the best welding position to achieve fastest possible filling passes. So all these angles you can set the way you want, and once they're set, and you're happy with the weld, then your welding program is done. So now I'm going to start the hot pass. Here it's fixed parameters, right or left if I need to steer. There we go. Now I have my override if need be. I'll just move a bit back so that I'm not too much welding light. So this is the hot pass right here. So what's really important is that to be sure that the arc is in front of the puddle as we have now. Hot pass is really critical. I can put a bit more voltage, steer a bit right, speed up or slow down a bit.
Chris?
Yes?
I just wanted to point out to everybody here again, as I mentioned in Zoom, the weaving pattern seems a little bit erratic, but it's actually quite smooth. It's actually the frame rate of Zoom that makes it look a little more different than what we're seeing in real life. And also prior to welding, the off arc image looked a little bit dark, but it's actually much brighter on the ROTOWELD screen than what we're seeing on Zoom.
So like what said before, we have a lock and unlock key. So once the welding program is done the way you want, if you put the key at lock and you remove it, the operator is only able to use the override. So he's not able to do main changes to the welding program. So the other important thing here that's really important is that we fine tune the weld. And once we're happy with it, let's say I'm happy right now with my 8-inch get 40 that I'm doing right now, and I want to weld a 10-inch get 40. Basically, what I would do is I would just copy this 8-inch and rename it 10-inch, and I'm pretty much ready to go. Then I just need to weld the coupon to make sure there's no fine tuning required, but it will be pretty close. So once you're there, so this is the cap that's starting right now. So once you've got a couple of welding programs to your taste that you fine tune, it's just a matter of copy, paste, and fine tune it a little bit. So you can build your welding program library to the way you want really quickly. I can put a bit more volts, so it crack a bit less, steer a bit. So it will perform the cap, and that's pretty much done for this weld. So we've been doing this a long time. This is the 3rd generation. I mean, we put all our knowledge in this machine. We feel that it's really up to the challenge. It's really reliable as well. So to increase productivity, get new jobs, this is the machine.
We recently had an installation with the ROTOWELD where it was in the crate on the Monday, and by the Friday we had passed 10 ASME X-rays with brand new operators of the customers choosing in their weld shop with 0 failures on 10 X-ray coupons. So with only 5 days for setup and training. So that's sort of an indication how mature the product is and how easy it is to use.
And also for us, what's really important is that when we go install the machine, we're working with the operator. So he uses the machine, he weld with the machine. So he knows what needs to be done to achieve the results that you want. We do not tell you how to weld. You're still the one that decides how to weld. So when we leave, you're able to do and perform welding programs to your liking. Later on, if ever need be, we can connect remotely as we are right now. We can actually look at you welding and help you out as well to support you. Same thing if ever hardware issue occurs. So we're almost done our filling passes now. At the end of the filling pass, I will just raise the head. And if I would have another weld to perform, I would move the carriageway, select the proper welding program, lower my head and start to weld. So it's really quick to position the welding head, and it's at the proper place every time. There we go. It's up to you, Paul.
Okay, thank you very much, Chris. All right, so now that our welding is finished, I can share my screen with our ProDataLog software, and I'll show you the actual videos and reports that we've retained immediately for traceability. Just a moment here. So here on the screen now is our ProDataLog, which we log into over the internet. A brand new machine here, so we have only performed 6 weld joints before, 48 inches. So we can look at it from a stopping standpoint. How many welds are we making that are incomplete? Do we have an issue with training or an operator who's performing wrong? We can see our welded quantity in terms of factored diameter inches, and we can take a look at our arc on time. We can judge these either against each other or on their own. Another thing we can see is interruptions, because we don't want to see stopped welds too often. So this really gives us our metrics for quality and for productivity. Scrolling down to our at view list now, I can see the actual welds that we just made. I can generate a PDF report. And here we have an inspection report, which tells us exactly what took place. We started our weld at 11:26 p.m., finished at 11:36, and it was a 9-minute weld. We can see our power settings. We can see our procedure that we used, and actually all of our parameters, everything in our background menus. So this is an inspection report. So this is what QA or QC might use to have an at-glance look before making the inspection. So they're up to date on how the weld was performed. Scrolling down, we can really graph anything we would like to. So we've graphed power in this case, but we could take a look at our amps. We could take a look at our travel speed. We can really generate any type of graph we want to look at the relationship of our weld. This is very, very good for any form of troubleshooting, gives us a lot of intuition over how the ROTOWELD is performing second by second. Most importantly, we have the ability to review all of our video footage. So this is where I can show you that we're in a much higher quality than sort of what we're seeing over the Zoom. So we can review. So when we do have defects, we can go back to the exact point in time when they occur. And for the ultimate traceability, we can also click and download these videos very, very easily. Same for our fill passes. So here we are with our one continuous fill pass. And again, it's all retained here on the video and savable. From the Pro Data Log, we can also review all of the parameters. And then we can come down to our logs and we can see every action that was carried out to finish this weld: pre-flow, root, fill pass, post-flow. And what we can do is we can actually graph any information that we would like to. So we can take date and time, travel speed, current, voltage, and we can make that into another report. And we actually have a second-by-second account and a very small file format for saving that shows us the exact weld time and the current, voltage, travel speed, and therefore we can also graph heat input, which I haven't, but we get the ultimate traceability, and it's in a very, very small file as a CSV file compared to a video. So these are the types of logs that could be saved and retained for years, taking up a very small amount of space on a hard drive. So that's our Pro Data Log. I see that there's some questions in the Zoom meeting, so I'm going to go back, stop sharing my screen. So some questions we have here. So this 8-inch weld, that took 9 minutes, David. So that it varies. We like to do a nice big cap pass. Sometime on a Schedule 40 pipe like this, we can do a root pass and a single fill pass in about 5.5 minutes. For sake of the demo and some talking time, and to have a very nice broad cap, we've gone with a bit of a longer weld, which took 9 minutes. The data with regard to file formats, I'll have to get back to you on that. I'll speak with our software division. And our solution for nozzles and flanges that need to be welded 90 degrees to the shell pipe. Some welds just aren't going to be turnable on ROTOWELD. We can really only do the 1G spool welds that are obviously in line with our axis. But we've had a lot of customers who actually, once they've adopted ROTOWELD, they've adapted their engineering for the ultimate turnability. So the shops that are really performing well with ROTOWELD are achieving about 85% turnability. Meaning they still got about 15% of joints that are going to have to be welded semi-automatically or out of position. So what we see a lot of is newer operators can do the 1G spool welding with ROTOWELD, and we can retain those higher skilled welders with the 5G and 6G tickets for that specific last 15% of the work. Some questions we had earlier, I'll go over to give you more time if there's any other questions anyone would like to ask. Does the torch have oscillation? Yes, it does. So we're able to control our weaving width through our menus as well as our weaving speed. So we can really tune in a nice weave with regard to our forward travel speed to give us really any appearance we want on that finished weld. Which materials can we weld? We can do carbon steel, high strength, low alloys, Stainless steels are very, very easy to weld because the same fundamentals with the Lincoln STT and the Lincoln Pulse modes apply to stainless steels very well. Very easy and very intuitive. We can weld Inconel alloys with the correct wiring gas combinations. And the Lincoln Power Source also has multiple welding modes for Inconel alloys, but we cannot weld titanium. The only reason for that being not that we're not capable, but titanium usually requires 100% purged environment. So quite common that it needs to be in some sort of purge chamber or bubble during welding. Can we zoom into the rack gear drive under the welding carriage? Question here from Mark. So what's the minimum pipe diameter? We advertise 3-inch pipe, but we actually have customers welding all the way down to 2-inch. We really worked hard with our positioner is designed and built in-house. So we actually design our own torque and acceleration patterns, and we have very smooth turning even down to the 2-inch diameter. And 1-inch would even be possible, but the use case and basically the ROI and the efficiency on a 1-inch with setup time versus weld time becomes very, very difficult. So while customers are still using it on 2-inch, we don't see very much smaller than that. And this, at this point, we're at the end of our demo and tour. So I'd like to thank everybody who joined. Thank you very much for taking the time out of your schedule. Again, we'll be able to distribute this video. It's all recorded, so everyone can rewatch if they would like, share with their colleagues. And most importantly, if you ever have any questions, you can reach out to us, info@rotoweld.com, and we'll make sure those questions or any technical info you need gets to you. Thank you very much, everybody.